Okay, ready for part B, you guys. I had to evict my little buddy because he kept, he was turning off the rocker switches on the power strip that my phone is plugged into right now. So that is not really going to work. So anyway, I evicted him. Okay, so let's go look back. We did our trinomials with common factors. That was smooth and easy. Let's talk for just a minute about subscripted variables, which is our second topic, as you can see in the book. Here's the thing. We're used to seeing equations, systems of equations that look like this, say 5x, and you can just watch this. You don't have to copy this right now. We're used to seeing things that look like this, right? It's a system of equations, and we're used to using substitution and elimination to mess around with those and solve them, right? That's not a big deal. What is going to happen in the future is we're going to be using these systems of equations to solve word problems. And the math you already know how to do, that's not a big deal. But when we're doing the story problems, we very often, as you have seen in the past, we very often want to choose variables that help us remember what's going on with our story. So rather than using x's and y's, we might want to use variables that look something like this. And what these are going to represent in our story problems is the number of nickels and the number of dimes that we need to, solve the conditions of the story. So rather than using x's and y's, in this section, John is introducing the idea that sometimes we're going to use variables that look like this, and they're called subscripted variables. Sorry about the pen skipping out. I'm going to switch for my next lesson. They're called subscripted variables. This little dealio is called a subscript, meaning it's just that little small number. It doesn't change anything about the calculation. It just looks different. So it's like putting eyeliner on our problems. It doesn't change anything. It just makes them look a little different. So we're going to practice using these variables to solve the problems we're used to doing. So here's example 71.5, for example. It looks like this. 5 times the number of nickels plus 10 times the number, whoops, this is supposed to be big, the number of dimes equals 125, and then number of nickels plus number of dimes equals 16. So that's a system of equations, and we're not going to let those kooky variables throw us. The instructions say to use elimination to solve it. So this is straightforward enough. We look at to see what we can eliminate. I can see that we've got singles of each variable down there. So my inclination is to say, let's multiply this bottom guy. Oh, look, I have a different colored pen. This will help. We're going to multiply this bottom guy by minus 5. Then the ends will eliminate against each other. So remember, there's lots of different strategies for doing this. This is the way John chose to do it, and it makes perfect sense to me, and so that's the way I'm choosing to do it. So here we go. We multiply this bottom one. We get minus 5, and then this becomes minus 5, number of dimes, equals 16. So there's our adjusted second. Remember, if we call this one A and this one B, then this is our new one, that's C, and we're going to compare that to our old A. So we're just going to bring A back down to right here, and that was 5 times the number of nickels plus 10 times the number of dimes equals, it was 125. Whoops, I said 5, but I wrote 6. And then those will cancel, and this will be 5 times the number of dimes equals, oh, I made a classic mistake, didn't I? I forgot to multiply this by this. So, my bad. 16 times 5, let's do it over here to the side. 0, 3, 80. So this should be 80. So now when I subtract it, I will get 45, I dare say, yes. And then we can quickly solve this by dividing by 5, that the number of dimes equals 9. And then plugging it in, I'm going to plug it into this original equation. We know that the number of nickels plus 9 equals 16. so the number of nickels must equal 7. Make sense? The calculation, you guys, it's exactly the same. We're not changing any of the math. We're just using these kooky double-lettered variables instead of simple x and y. So go ahead and try 71.6, and I think you'll see that it's straightforward, and that is the second part of lesson 71. Awesome. Thanks.